Let's begin by taking a look at the function f of x equal to x squared minus 9 divided by x minus 3. And eventually we're going to look at finding the limit of this function as it approaches a certain x value. But first we're going to graph it. Now notice this function is a rational function. And sometimes rational functions will simplify. And this one will. So let's first simplify it. F of x equals, we can simplify it by factoring that numerator. It is a difference of two perfect squares, so it factors into x plus 3 times x minus 3. And then we still have the x minus 3 on the bottom. Now notice the x minus 3's cancel, so we're left with the function f of x equal to x plus 3. But we need to be careful here. We eliminated the denominator. The denominator has an impact on what the domain of the function is. Notice with the denominator, if we try to plug 3 in for x, we create a 0 in the denominator. So we need to make sure and exclude 3. Okay, so now we've defined the function as f of x equal to x plus 3 with the condition that x is not equal to 3. Okay, so now we're ready to graph it. Notice that f of x equal to x plus 3 is a linear function, so the graph of it looks like a line. It has a y-intercept of 3 and a slope of 1. So plot the y-intercept 3 and a slope of 1. Plot a few points here. And there's our line. Now, what about the condition x is not equal to 3? So that means at 3 we need to put a hole there. Okay, so there's our graph. Now the first question asks us, what is f of 3? Well, we just got done saying that x can't be 3. 3 is not in the domain. So f of 3 then is undefined. Now in part B, it asks what is the limit of f as x approaches 3? So in this table, we're first going to look at when x approaches 3 from the left. That's what that little negative sign means in the exponent. It's not really an exponent, it's a way of indicating that we're approaching 3 from the left. So as we approach 3 from the left along the x-axis there, for example, say x is 2.9, that's pretty close to 3 from the left. What do we get as a function value? Well, if we try plugging 2.9 into the function, we have 2.9 plus 3, and that gives us 5.9. Okay, now what if we try 2.99? That allows us to approach 3 even closer from the left. So then we're looking at 2.99 in for x plus 3. So we get 5.99 as our function value. Okay, and then if we continue to get even closer to 3 from the left, we could use, say, 2.999, for example. Plugging that in for x, we have 2.999 plus 3, which leaves us with 5.999. Okay, so as we approach 3 from the left, it looks like our function value is approaching 6. We're getting closer and closer to 6. And we can see that in the graph. As we come, our function value is approaching 6 as we come in along the x-axis closer and closer to 3. Okay, now let's do it from the right side. So in our table we have as x approaches 3 from the right, and that's what that little plus sign looks like a little plus exponent. And when we see that plus, it means we're approaching x now from the right side. So if we look at our x-axis in our graph, as we come in from the right along the x-axis, as we approach 3, what is happening to our function values? So, for example, if we plug in 3.1 in for x, f of 3.1, that's pretty close to 3 to the right. If we plug that in for x, we have 3.1 plus 3, which gives us 6.1 as our function value. Now if we want to get a little bit closer, we could use, say, 3.01. If we plug that in for x, we have 3.01 plus 3, which is going to give us 6.01. Okay, and then even closer still, we could use, say, 3.001. Plugging that in for x, we have 3.001 plus 3, which is 6.001. So now notice that as we come in from the right side along the x-axis and we're approaching 3, what is happening to our function value? Well, if we look up at our graph of our line, our function from the right is approaching 6. So notice that from both the left and the right side, our function is approaching 6. When we have the limit from the left equaling the limit from the right, then we can say that the limit exists at that x value, and it equals, in this case, 6. When the left and the right-hand side equal each other, then we have a limit, and in this case, we say that the limit as x approaches 3 of the function is equal to 6. Now, if we get different values for the left and for the right, then the limit does not exist. So the limit from the left and the right have to be approaching the same value in order for the limit to exist.